Hello, this talk is about entity recommendation for everyday digital tasks. Our digital lives is composed of receiving, processing, communicating, producing information. In order to do so, we tend to organize all of digital activities around tasks that can be contextualized by entity, for example, application, documents, people, and several keywords determining a task. However, computer systems do not organize the information in task contexts, do not allow users to find the information in this way, but require user effort, cognitive attention in formulating a query. In addition, it is hard to record information in the first place, what information is needed, name of the documents, and people also often forget to use the documents even though they are stored in structured folders appropriate location. User tasks can highly benefit from a system that recommends the right information to use at the right time. So we introduce the EntityBot, recommend a system that captures context and recommend cross-application, cross-platform entities. So the user context is determined by continuously monitoring all of digital activities on the screen, including application being used, document being opened, and the system can also capture the content that are visible on the computer screen by taking screenshot every 2 seconds, convert screenshot to text using optical character recognition. A prediction model is then applied on the monitoring data to infer the user task and discover real-time information needs, and consequently contextually recommend relevant entities. So I will show you a video how the EntityBot actually works. So there are 2 parts in the video. First part is 24/7 digital activity monitoring for 14 days. And the second part of the video is entity recommendation. So the system continuously monitoring computer screen for 14 days, taking screenshot every 2 seconds. And then it captures all of digital activities and even the content inside the screen. So in this video, the user is trying to work on a writing task, and the recommender system is set up in the upper screen in the video. So while users performing a task on a laptop, the recommender system provides recommendation in response to the user's actions. For instance, it recommends the people entities in the first row on the recommender system user interface, and the application entity on the second row, and the third row is document entities. The last row is keywords. The users can use the recommendation, for instance, can open a document, or the user can also provide explicit feedback on the recommender system, for instance, selecting the entity of interest, and then the model updates the recommendation according to the user selection. So essentially, the EntityBot supports data integration. So conventional way of computer system integrate the data is that they put entity into different folders, files, web directories, or different database, or even in a cloud. But then now with recommender system, it synchronizes all of the information and the content in a common place, provide access to entities from multiple sources. So in this research, we're trying to understand the influence of recommender system on the user task performance. So we carry out field study, which include two main phases. The first phase is 2-week digital activity monitoring, and the second phase is a lab study, in which the users, after 14 days, they come back to us, and we ask the participant to work on 2 different tasks, and we assign those tasks into different conditions. The first condition is control condition, in which there are no recommendation visible to the users. And the second condition is experimental condition, in which recommendation is visible to the users. So this is the overview of experimental setup and the study condition that we use. So we also define the following 2 research questions to understand the difference between the experimental and the control condition. So we measure the relevance of recommendation, and then we also measure the influence of the recommendation on the user task performance. For instance, whether the user pays attention on the recommendation, how much the user use the recommendation, or whether they interact with the recommendation system. We also interview the users to extract their subjective experience with the recommender system. So these are the tasks that people select and work with in the experiments. So this table summarizes the results for one of the measures. We found that the record was high in both control and experimental condition. This indicates that user model can find more relevant items or entities compared to what the user could find by themselves. We also observed that in the experimental condition, the number of application participants used for the task was significantly higher compared to in the control condition. And we found that participants still focus more on the main task because they only spend 1.3 minutes on the recommender system user interface. Participants also report a positive experience with the recommender system. We found that the feedback mechanism is very important in improving the quality of recommendation. Recommender system allow easier retrieval and immediate access to document and application. It also reminds the users about specific activities or piece of information, and it can be a source of inspiration from what we have in the interviews. So to conclude, the entity-based approach in our system has several benefits. First, prediction works very well. Information is recommended and readily available without user needing to search for. And second, the entity selection was found to be simple and effective. User feel in control because of explicit feedback they can provide to the recommendation. And finally, recommendation provide more actionable information item. For example, action can be done on the entity. Seeing a recommendation of a person can signify an action such as calling, texting, emailing, and document recommendation can also allow instant access to related resource. Thank you.